This video will cover the introduction to the fifth lesson of the matrices unit, and that is how to carry out transformations using matrix operations. And this is discussing an application of matrices for the first time. Up to this point, all we've really been doing is operations on matrices, things that can be used to actually perform real-world operations. So, today, in this video series, and there should be a total of, I believe, 5 videos in this series, we will discuss types of transformations from geometry and how we carry them out with matrices. There are 4 types of transformations from geometry. We have reflections, or flips, whichever way you learned about it in school. Translations, more commonly known as slides. We have rotations, occasionally taught as turns. And we have dilations. Now, dilations are unique. There are actually 2 different types. You have enlargements and reductions, depending on whether you're making your object larger or smaller. Now, matrices can be used to reflect, translate, dilate. Or rotate. Using the various matrix operations that we have already discussed, what we use is what's called a vertex matrix, which will be the other focus of this particular video, and various matrix operations, including, but not limited to, actually I guess they are kind of limited to, addition, subtraction, scalar multiplication, and matrix multiplication. So in order to do this, we first have to understand how to use a matrix to represent a shape. So here we have a triangle, ABC, and we're going to talk about how to turn that triangle into a matrix, how to turn that picture on the coordinate plane into a matrix that we can use to represent it. So what we do is we write what's called a vertex matrix. A vertex matrix is a matrix which contains the coordinates of important features, i.e. your vertices of a figure. So this particular shape, triangle ABC, has 3 vertices, point A, point B, and point C. So what we do is we come up with the coordinates of those points. For instance, point A is located at -4, -6, left 4 and down 6 from the origin. Point B is located at point 2, 5, right 2 and up 5 from the origin. And point C is located at, 8, -6, right 8 and down 6 from the origin. So we can represent triangle ABC by using what's called a vertex matrix. Now this matrix will contain 2 rows. One row will be for the x coordinates and 1 row for the y coordinates, and 3 columns, 1 for each vertex. For instance, A, which is located at -4, 6, would be represented with a column listing -4 first and -6 second. The x coordinate is listed first, the y coordinate is listed second. B is at 2, 5, and C is at 8, -6. Now it doesn't necessarily matter what order you list those columns in. It is common practice, though, to list them in the order that they are connected. So we could have easily switched the second and third column and we would still have an appropriate vertex matrix for this triangle. In fact, since it's a triangle and there's only 3 vertices, you could list them in any order. But for instance, if this were a pentagon or a hexagon or something larger, you would need to pick a starting point and then work your way around the outside as you created the vertex matrix. Now what this vertex matrix tells us is the location of each point, x, y. The entire first row is x coordinates, the entire second row is y coordinates. So I can pick out any particular column, and that column will give me the coordinates of an important point. This way we can perform various operations on the picture without actually having the picture. So the next video in this series will cover translations, the one after that will cover dilations, the one after that will cover reflections, and then the final video will cover rotations. So please feel free to pick and choose which one you need to see to truly understand what you're doing.